Last lesson for the chapter. I hope that you've gotten at least most of this stuff under control. I think I told most of you last week, I tried to tell most of you last week that you wanted to go ahead and focus on 1 through 6 so that this week could be short and easy. I hope that you are there. If not, you need to start making sure you're wrapping this stuff up. The test is in 3 days. So other than that, we talked about probability yesterday. We learned the probability of success over total. But now we're going to talk about compound events. What does that mean? It means it's not what's the probability of getting heads on one flip, it's the probability of getting heads on 2 flips, 3, 4, 5, or 6. Compound, kind of like a compound sentence, has more than one part. Compound events means you're doing more than one event, and you want to find that. Today we're going to consider how to find the probability of multiple events. This is done using a similar system to what we did before, but before moving on, write the following key information on your paper. The probability of event A and event B you will multiply, just like we did with the blanks game that we did when we were doing permutations and combinations. So you will find the probability of event A, you will find the probability of event B, and you will multiply those two if you see the word and. If you want the probability of event A or event B, then you find the probability of event A, find the probability of event B, and you add the two together. And that is the key part of what you need to understand when it comes down to probability of compound events. And means multiply, or means add. Think about it. And is a lot tougher, which means you're going to multiply them. Or is more loose. It doesn't matter which one you pick. A and B means I have to get both, so I need to multiply them. That's tougher. A or B means, either one works. So again, it's kind of loose, so you're just going to add those up. But whatever you got to do, just make sure you understand how that works. You're going to see a question like this on your test. It's really not that hard if you understand the wording. They are telling me the probability of event A is 0.31, or about 31%. They're telling me the probability of event B given A is about 56%. What this means is, again, you have two events. The probability of event A is 0.31. But they're saying that if A has already occurred, that's what this means. B given A. So if you've already selected A, what's the probability of selecting B? That would be your 0.56. So again, probability of B given A means that A already occurred. What is the chance of B occurring? That's 56%. And they want the probability of A and B. This is again wordplay. A and B, we already learned that A and B means multiply. So all you got to do is take 0.31 times 0.56. and you will get your answer, which is 0.17. Again, round to the nearest hundredth, and that is what we have. Alright, should be an easy question as long as you go with your gut. And means multiply, or means add. Problem 2, again, looking at this, it says you select from bag containing 3 blue, 9 gold, 6 white marbles. You return the first marble to the bag before choosing another. Find the probability of blue and gold. The key thing here is that I return the marble. Alright, remember I talked about on the permutations, I forget which video it was, but I know I talked about the replacement factor and how if you put it back, then it keeps the numbers the same, but if you take it out and don't put it back, the numbers change. Well, that's key. You want a blue and gold marble. So here's what we do. We are going to make 2 selections. So we're going to kind of use that selection process, but we're not just going to put numbers, we're going to put fractions down there. So we've got 2 selections. What is the probability of selecting a blue marble? Again, success over total. Blue, there are 3 blue marbles total out of 3, 12, 18 altogether. So this would be your probability of selecting a blue marble. The thing is that I put the marble back. If I did not put the marble back, then you think about it, this would now have 2 blue marbles left, and there would only be 17 left, so each of those numbers would drop 1 if I did not return it. But I did return it. Now I want a gold marble. So if I did put that back, I now have successfully 9 gold marbles out of, again, if I put that first marble back, there are still 18. So now what I'm going to do is multiply those 2 numbers the way that you've been taught, which is, if you're going to use your calculator, use parentheses. So 3/18, 3 divided by 18, times 9 divided by 18 equals, and then I guess we can leave it as a decimal because that's what we want anyway, and our answer is 0.08. That is the probability of selecting a blue and gold marble. So again, using the strategy that we used before, use the blanks. We're picking two things, put a blank on each one, figure out each one individually, and multiply. The probability of a blue or gold marble is different though, because now what we're going to do is actually take those two numbers and add them. So blue or gold means, again, the blue we found out was 3 over 18. The gold was 9 over 18. But again, we're talking or, which means that we are now going to add those two, because it doesn't matter which one we pick. Blue or gold really isn't two selections, it's one. But since you've got two different events you're talking about, we're going to find the probability of each event and then add those two events together. So we now do 3/18. Actually, I don't think we need that. Common denominator, 3 plus 9 is 12 over 18, which means that we do 12 divided by 18. Oops. 12 divided by 18, which is 0.67. So overall, I guess what you can say is this is not that tough as long as you understand that and means multiply, or means add, and I'm assuming that you again did the majority of what you needed to do last week, and that you understand how the blank system works, to where you put your blanks down for how many selections and you go from there. Problem 3 says a grab bag contains 11 black chips, 8 blue chips. An experiment consists of taking a chip out of the bag and then selecting another chip. What is the probability of selecting a black and blue chip if the first chip is replaced? That is important. The first chip is replaced. Again, I want a black chip and a blue chip, so I put my two blanks. The probability of selecting a black chip, success over total, is 11 out of, looks like 19, because there are 11 black chips and there are 19 chips altogether, because 11 plus 8 is 19. That is the probability of selecting a black chip. A blue chip, the successful number of course is 8, but the question is, I put it back, which means that your number on the bottom is still going to be 19, because my 19 chips are still there. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So again, what I did was I drew this chip out, which put us down to 18, but then I put the chip back in the bag to choose from, which is why you're still at 19. Alright? But again, this is and, a black chip and a blue chip, which means we're going to multiply. So we do 11/19 times 8/19, which is 0.24. That's all. Okay, that's all it takes. Give me a decimal answer. Don't worry about turning it into a fraction, because probability is a decimal answer. Now you want if the first chip is not replaced. So your first probability is still going to be the same, because when it comes to the black chip, there are still 11 out of 19. But like I drew here earlier, if there were 19 chips and I took one out and did not put it back, now there are only 18 chips, which means that when you do your second one, there are still 8 blue chips to choose from, but there are only 18 chips to choose from in the bag. Alright? So again, the difference between the two, if it's not replaced, is that when it is replaced, the 19 stays 19. If I did not put the chip back, that means that there are only 18 chips in the bag on my second draw, and that is the difference that you need to make sure you understand. So what I'm going to do is cheat here and draw it back up and just turn this 19 into an 18, getting the answer of 0.26. But other than that, that's really the things that you need to be ready for this week on your test. We got one more to look at, and then you get to go to Math Excel and start wrapping up your week and getting ready for spring break. A bag contains 7 white balls numbered 1, 2, 3, 4, 5, 6, 7, and 3 red balls numbered 8, 9, and 10. If a ball is drawn at random, what is the probability that the ball is white or odd? White or odd. So I've got 2 selections to do, and what I do is I take the probability of finding a white ball. So there are 7 of them out of 10. Odd numbered would be 1, 2, 3, 4, 5 of them out of 10. Again, white, there are 7 successful, 10 total. Odd, because remember, you're still going to have 10 no matter what. Odd is 5 of them, because 1, 3, 5, 7, and 9 are all odd. But the key word here is or, which means that we're going to add 7/10 and 5/10. Whoa. Something's wrong. Actually, that's not what we do here. Adding means that we just put the number together. So white, there are 7 white balls there, so 7, and you add in the number of odd, which is there's one more number there that is odd. So there are 8 successful things that we can take out of that bag. So again, each of these wouldn't matter anyway because there's 1, 2, 3, 4, 5, 6, 7. So it wouldn't matter if they're odd or even because they are white. But the thing you need to keep in mind in here is that we also allow an odd one in here, and so this gets added to the list, which means that there are 1, 2, 3, 4, 5, 6, 7 successful draws here because they are white. One more successful draw here because even though it's red, it's odd, which means we are talking about 8 out of 10, which is 0.8 as your answer. Sorry about that, but I think that this is because it is overlapping events. But again, what we looked at here is just making sure you think about it, because again, that would have given me 12 tenths, which is impossible. You can't have higher than 1. So I'm glad that I made that mistake, and you can kind of keep an eye on that too. 7 tenths and 5 tenths makes 12 tenths, which is bigger than 1. That could not be the situation, so I knew to go back and think about what was going on. Other than that, go to Math Excel, start working on wrapping this stuff up, and again, make sure you're asking questions, getting ready for the test. That will save some of you. It'll take others of you and put you in a comfortable position. And for others, I hope this isn't you, but for others it'll put you in a bad spot with only about 5 weeks left of work. So I hope that that's not what happens. Make sure you work as hard as you can on making sure you're in the right spot when we come back next week. Good luck.